because it has the exact same thing on both sides. Nothing has changed. 3 equals 3 would be an example of the reflexive property. Where we're going to see it a lot is we might say that these two segments are the same segment, okay? And believe it or not, this is going to be one of the properties that we use a lot as we go throughout the year, okay? And so it doesn't seem like it's a statement that we really need, but as we start doing proofs, this is going to be a statement that we're actually going to use quite a bit. Because we're going to say this side is congruent to this side. Even though it might be on two different triangles, we're going to say this side and this side are the same. Okay, same with an angle. Measure of angle A equals measure of angle A. Those two are exactly the same. So reflexive, if I look at myself in the mirror, what do I get back? I get the exact same image, right? And so it's not spelled the same way, but you can kind of think of it as reflexive and reflection kind of similar, right? You get the exact same thing back. That'd be kind of freaky to look into a mirror and get a different image back, right? Symmetric property, we're going to flip-flop the sides, okay? If A equals B, then B equals A. You could do something like this. If X equals 2, then 2 equals X. We talked about the symmetric property yesterday, okay? And the reason I went ahead and threw that in yesterday was because we saw some problems where we were using the symmetric property, so I wanted to go ahead and make sure that you had seen it before. Okay. Notice here, the only thing that happens is AB and CD flip sides, okay? If I tell you that AB is equal to CD, then I can restate it and say CD is equal to AB. Same for angles. If I say angle A is equal to angle B, then I could restate it a different way and I could say angle B is equal to angle A. Okay, so if one person told me this and somebody else said angle B is equal to angle A, aren't we essentially saying the same thing? Yeah, that's what the symmetric property is saying, okay? It doesn't matter which way you state it, it's still stating that those two angles or segments or whatever are the same. Okay, the transitive property, I kind of think about like you're transitioning, okay? This is very similar to the law, the law of syllogism that we talked about a week ago. Okay, the law of syllogism, remember we took two if-then statements, we combined them together to make a third. We're going to basically do the same thing with the transitive property. In this case, A is equal to B and B is equal to C. So since they're both equal to B, then guess what? A is equal to C. Okay? So all three things are equal. So here would be an example. If 2 plus 3 equals 5, and 5 equals 4 plus 1, then 2 plus 3 equals 4 plus 1. Okay? Because they're both equal to 5, then they are equal to one another. Sometimes I like to do examples with some numbers in it. Maybe it makes a little bit more sense. We know this statement's true, we know this statement's true, and since they both equal 5, then they can equal each other. Okay? We're just making a new statement with the statements that we were given. But they have to have a common link, right? Same as we did with the law of syllogism. If they don't have that common link, we can't combine them together. But it's called the transitive property. You can do it with segments. If AB is equal to CD and CD is equal to EF, since they're both equal to CD, then AB is equal to EF. You can do it with angles. Angle A is equal to B, B is equal to C. Since they're both equal to angle B, then they are equal to each other. Okay? So all of those are the same thing, just using an angle, using a segment, or just using a basic old equation stating that they're equal to the same thing. Okay, so down here, and we're going to do some more of this at the end of the day, or end of the lesson today. But these are only the three we just got done talking about. The one we're going to do here in a little bit is going to bring in everything. All the properties from yesterday and the three we added on today. If angle 6 is equal to the measure of angle 7, then measure of angle 7 is equal to the measure of angle 6. What's happening here? What's different? What changed? Is anything different? They flipped, right? So it can't be reflexive because it's not saying like angle 6 equals angle 6, right? So reflexive is out. If they just flip-flop sides, Adrian, what would that be? Okay, let's pay attention. Okay, what happens when we flip-flop sides? Symmetric, yep. And so we would just call this the symmetric property. And these are all properties of equality. Later on, we're going to see like the symmetric property of congruency. And so it is important to go ahead and say equality on these because we're just using equal signs. Okay. The key here is JK is equal to KL. KL is equal to 60. Therefore, because they both equal KL, that's going to be kind of the common link, right? Then we can say JK is equal to 16. What are we using? Transitive. Yep. We're taking two statements, combining them together to make a third. And I'm still good with abbreviations, okay? Okay, the third one. Angle 1 is equal to angle 2. Angle 2 is equal to 5. Therefore, angle 1 is equal to angle 5. What's that?
Transitive.
Transitive again. Yep. Because they both equal angle 2, then they equal each other. Transitive out of the three should be pretty easy to identify because you're combining two statements to make a third. Reflexive should be pretty easy to identify because it's the exact same thing. Symmetric, you're just changing sides, flip-flopping sides. ZY is equal to ZY. What do I notice about the two sides of the equal sign? They're exactly the same. Nothing's changed. No letters are flipped. Nothing is different. They're exactly the same. So that would be the reflexive property of equality. Okay. All right. This is a little bit harder than the proofs that we did yesterday. So read through this statement first, and then we're going to talk about drawing a picture, and then we're going to write a proof out to talk about what we're trying to prove. Okay? So read through that little paragraph first. Okay. We have 4 stores, or 4 locations, I should say. Park's not a store. So we have a park, a shoe store, a pizza shop, and a movie theater. So I just made like a segment, okay? And I put locations at different spots. I just labeled them with P, S for shoe. Since I already used P, I can't use P for pizza. I gotta use a different letter, so I use Z for pizza, and then M for movie. Okay, so those are my 4 locations in that order, okay? So that's the first thing. And I went ahead and equally spread them out, or it kind of looks like equally, but we don't really know yet. I just put them all on a number line, okay? The distance between the park and the shoe store is the same as the distance between the pizza shop and the movie theater, okay? So how would we show that on our picture? If two things are the same length or distance, how would I show that?
The congruent symbols.
The congruent symbols, right. Okay, so the distance from the park to the shoe store is the same as the distance from the pizza shop to the movie theater. So that little marking shows us that those two segments are the same. We don't know what the actual length is, but we know they're the same, okay? Show that the distance between the park and the pizza shop is the same as the distance between the shoe store and the movie theater, okay? So, we got to write a proof. And as we write this proof out, okay, we don't know this distance, right? If I knew that distance, then that'd make it be a little bit easier. We just don't know that distance. Yesterday, the given statement was really easy, okay? Because it just said, here is the given equation. Today, they don't just give me a given equation, but is there any given information that they provide us if I look at the picture? Is there anything we could say that we're given or that we know? Great, good job. PS, and that's why I used letters here. PS and ZM are equal, right? And that's why drawing the picture here is helpful. We know those two are equal because that was given to us. They told us that in the paragraph up here that those two are equal. So we just call that given statement because they gave it to us. We can't just assume that to be true. Okay. Now, what we're trying to do here, the distance between park and the pizza shop, okay? So to go from park to the pizza shop, if I just cover this up, what two distances will get us from the park to the pizza shop? Well, I'm going to go from park to the shoe store, and then I'm going to go from the shoe store to the pizza shop, right? So what I'm going to say here is PS plus SZ equals PZ. This length plus this length equals the whole thing, right? Everybody good with that? Like what we're saying? If I told you that this was 5 and this was 6 blocks, then 5 plus 6 would be 11 blocks, right? But we're not using numbers, we're just using distances here, okay? Same can be true for the other ones, right? If I did from the shoe store to the movie theater, what would that look like? How would I write that out? SZ plus ZM equals SN, okay? And I'm going to write that like that. Okay. Now, as we look at this, what did we do here? We're adding, and what are we adding? Distance, yeah. And what would I call PS? What kind of geometric symbol is PS? It's a segment, yep, because it's 2 points, right? So there's a postulate that we did earlier on that we said we can add 2 segments together to make the same thing. Okay, that was what we called the segment addition postulate. Okay. So then the next thing. What we could do then is rearrange these a little bit, right? If I told you, and we could probably state this a little bit differently, but because I know these are both the same, right? PS and ZM are the same thing. I don't know what SZ is, but if I told you that this is 6, let's just use a number as an example here. If this is 6, then this has to be 6, right? Because those two have to be congruent. What do I know about these two? Okay, and these two, well, they both have SZ in common. Okay, so here's what we're going to do. We're going to do PS plus SZ equals SZ plus ZM. PS plus SZ equals SZ plus ZM because of the common piece that they have. Okay? What do you think we would say there? Yeah, so it's a little bit tricky here, right? We can't necessarily say transitive because we don't know that for sure. Like, transitive would have to have something in common here, okay? So what we're really doing here is we're just kind of combining like terms, right? We're just saying, well, because they have a common piece in tow here, SZ is kind of a common piece, then we're combining the like terms together. Okay, so now here is the last thing. We got to go back up here. Show the distance between the park and the pizza shop is the same as the distance between the shoe store and the movie theater. PS and SZ is equal to SZ plus ZM, right there, okay? So to finish this one out, what is PS plus SZ the same as? PS plus SZ is really the same as what? PZ, right? So this can just become PZ. This SZ plus ZM is really equal to SM. So PZ is equal to SM. The distance from the park to the pizza place is the same as the distance from the shoe store to the movie theater. That's what we're trying to prove. What's my reasoning here? What did we do? This is a property from yesterday. If these two are the same thing, I can take PZ and replace this. What's another word for replace? Substitute. Yeah, you're substituting it in. So this would be the substitution property of equality. Okay, a little bit tricky proof, a little bit different than some that we've done last and yesterday. Okay, we're going to see some problems like this on Big Ideas today. I'm going to give you a little bit of time. I want you to answer all of these. Shouldn't take you more than about 5 minutes to answer these. You can use your notes if you need to, and then we're going to go through these together. This is not homework. This is gonna be something we're gonna do in class today. I'm gonna give you about 5 minutes to do this. I want you to do this first. Because properties are kind of new. Trying to identify anything's a big deal. So it's just matching, okay? And you will use some of them more than once. So we have more problems than we do properties. So some of them will be used multiple